In this video, we're going to be talking about linear bar grill auto-sizing functionality. I haven't said this in the previous two videos, but generally speaking, I'm demoing supply diffusers and grills, and a lot of this functionality applies to the return grills as well. So we included performance tables for what we could. We'll be adding more over time, but a lot of the return grill families have the same functionality. So linear bar grill families. These are based upon Titus's families. We've talked about host family functionality. Here's the families that we have. We have supply and we have return. So I'm just going to place one of these, and then we'll talk about the auto-sizing properties. So these can be placed on a vertical face. These can be placed just like everything else. So I'm going to place this on the wall. And let's give this an elevation of 10 feet. So one thing I want to point out is these supply grills have a system classification already designated as supply. However, the return grills and return families in general have been set to global so that these could be used for exhaust air or return air system classification. So be aware of that, because you could use this as a supply air classification. So don't do that. You can define this to begin with, or you can select a duct nearby and add it to it. It all depends on what you've modeled so far, but a lot of times I'll create a duct system and I'll say this is going to be return air right here. So now it's defined. Now you can just click on the dot and start drawing a duct, and you're good to go. So just be aware of that when you're doing return. So once again, we've done everything we can to reuse content as much as we can. So we don't want to have separate return and exhaust grill families when it's the exact same model number from the manufacturer. All right. Auto-sizing functionality. I'm going to move this duct up to 8 feet. And let's throw a tag on here and let's talk about some things that's going on. All right, so like we've talked before, constraints is your command center. The only thing that's different is now we've added another selection point, which only makes these families even more powerful. So now we're not just sizing off of airflow per length, or typically airflow per foot is how it's used in the US here, but we're also going to size off of NC values. So let's give this some airflow. Let's say 400 CFM. So the first thing is this 80 CFM per foot is going to be used to size the length of the grill. So in that case, we have a duct width of 5 feet. So these diffusers are a little unique, where width and height is actually rotated compared to the rest of the families. So we included a length and a width parameter. However, diffuser width here should not be confused with duct width here, because they're actually inversely related. So right now we're at 5 foot length. If you wanted to override that with all the other families, you can. So now we're at a 4 foot length. So just be aware, diffuser length is the duct width, and diffuser width is the duct height. And width is how the manufacturer referred to it as, so that's what we went with. All right, let's talk about auto-sizing. So right now we're getting throw data. So we have a 29, well, once I made that last update, we have a 26 NC, and our design NC was 30. These families, though, have something unique as well, because there's correction factors based upon if you're something other than a 4 foot width. And we have that down in the mechanical properties. So once again, instructions, very important. take a look at these before you start looking at the numbers and trying to decipher what's what. So this says autosizing does not initially take into account noise criteria correction factors for lengths other than 4 feet. So I guess what I'm saying is you may see an NC value here of 31 or 32 if you, once the correction factor is applied. I can't, we can't do multiple iterations at this point with this type of functionality. So you just need to be aware of that. And if you are going to have an 8-foot diffuser, then you probably want to lower your design NC so that you stay below 30. So right now we're at 5 feet, so we don't have a correction factor at the moment. If we change this to, let's do 60 CFM per foot. So now we're at a 7-foot grill, and now we do have a correction factor. So NC correction is 2.5. And then the final NC, so this does include the correction factor, we're at 26.5. So everything looks good here. Now let's go and check some data points. So let's go down into data. You'll see, so airflow per length lookup is 60 CFM, and diffuser width lookup is 2 inches. Just say, for example, we put this at 58 CFM per foot. So we still have a size found. However, okay, 58 CFM, okay, I stand corrected. So that value still is looked up and it's being checked to find something greater than. I'm going to put this back to 60. And let's open up the web page and validate a few more data points. All right, so what kind of family do we have here? I'm going to take a look back. 1/4 inch spacing, 1/8 inch thickness, 0 degree deflection. So let's scroll down. Oh, right here, 1/4 inch spacing, 1/8 inch thick bars, 0 degree deflection. So now this autosizing process works a little differently. We are autosizing the width based upon the CFM per foot that we can find if it meets the criteria. So in this case, let's move this over to here. Let's slide this over. Okay, so we're looking for 60 CFM per foot. I'll slide this down just a little bit. Okay. So the way this autosizing works is it starts out at the smallest size. So we're looking for 60 CFM per foot right here. Now, is the NC met? Yes, it is. It's below 30. And now, so here's my selection. So it's a 2-inch size, and what we have to do is now we've included the, well, yeah, let's look at the correction factors. So for NC, if you're 4 feet, it's 0. If you're 6 feet, it's 2. So we've done some interpolation in this to get a correction factor. Like we're at 7 feet. So our correction factor is 2.5. And sure enough, that is what our family indicates. The throw correction now, we're at 7 feet. So we're somewhere in between these two. And our correction factor is 1.375. And then here's the modified throw performances. So I think that's safe to say that we just validated another data point. Let's play around with this though. Let's say we wanted a design NC of 20. That's pretty low, but let's just do that. Let's hit apply. So as you can see, the width updated to 2.5 inches to comply with that criteria. So if we look at this again, So 20, so now this doesn't work, so we go up to the next size, 2.5, and we're looking for 60 CFM per foot again. Here we are, it's an NC of 15, that works, and here's our performance values before adding the correction factors. So that's essentially the linear bar grills. We've tried to put initial default design values in here to keep noise values below an NC of 30. However, it's up to you guys just to be aware of that. And then if this was at 100 CFM, we'd be at 4 feet. There'd be no correction factor found or needed in this case. So return is very similar. There's just no throw data. So these auto size in the same fashion. There's just no throw data. So right now this return grill is at 25 NC and it's at 100 CFM. So if we wanted to elongate this, let's go to 4 feet. So the duct is not going to work in that case. The NC goes to 0, and it's not actually 0. It just means it's unrated by Titus. So these 0 values essentially means that there was a dash shown in the performance table, like for example this case. So this dash represents a 0. There we go. 2 more points validated. Hope you guys enjoy.